This one's going to be an example of taking a solid that's given to us in rectangular coordinates and converting it to cylindrical coordinates, and then ultimately evaluating the integral in those cylindrical coordinates. So first, let's take a look at the solid E. We're given the set of all points x, y, and z such that x squared plus y squared is bounded between 0 and 4, y is bigger than or equal to 0, and z is bounded between 0 and x plus 3. And we've been given a particular function that we're going to be integrating over x squared plus y squared. So we are talking about the triple integral over the solid E of x squared plus y squared dv. And of course, if we're going to do this in cylindrical coordinates, we do want to remember that dv is given as r times dz dr d theta. And now it's just a matter of converting everything over. So let's go back to our region, our solid E, and I'm going to take the first two parts of this expression here and use those to investigate what's happening over the region D in the xy plane. So if we look down on that particular region, the first part of this says that x squared plus y squared is bounded between 0 and 4. So effectively, if we were to think about the fact that x squared plus y squared is equal to r squared, this is really saying 0 less than or equal to r squared is less than or equal to 4, or 0 less than or equal to r is less than or equal to 2. So it's really just a circle of radius 2, and we're taking everything from 0 all the way out to 2 to define this full circle that we're going to use as our region D. There is a second piece to this, and it indicates to us that y should be bigger than or equal to 0. So y is bigger than or equal to 0 as long as we're to the right of the y-axis. So combining those two together, we get a region of integration D that lies in the xy plane here that is really just the half circle going from minus pi over 2 to pi over 2. So between looking at this particular region and the bounds we've set up here, we actually know exactly how to sweep out this region. And that would be by taking r to go from 0 to 2, and taking theta to go from minus pi over 2 to pi over 2. And now I've got that portion of our region converted. The last part is to convert over the surface to surface piece, so from the bottom z to the top z, and that will go pretty easy as well. 0 less than or equal to z. Using our conversion from rectangular to cylindrical, we know x is equal to r cosine theta. So it becomes r cosine theta plus 3. So now we have all three bounds that we need for our solid. So let's take those down and we'll set up our triple integral. So now we're going to integrate on the outermost the theta minus pi over 2 to pi over 2. The next integral will be r, which is going to go from 0 to 2. And the final inner integral is going to go from surface to surface. That's going to be 0 to r cosine theta plus 3. Now the only other thing that we have to do is we have to make sure that we convert our integrand as well to cylindrical coordinates. And we do that using whatever conversion suits its purpose best. In this case, again, we know x squared plus y squared is equal to r squared. So we can simply replace that with r squared, and then we'll bring in our dv down below. So times r dz dr d theta. And there you have your triple integral. Again, at this point, it's just going to be a matter of working through the integration itself. Let's take the first step at that. So now we'll take the antiderivative with respect to z. Of course, there's no z in the integrand, so we'll pick up a factor of z. So r cubed times z. We're going to evaluate z from 0 to r cosine theta plus 3 dr d theta. taking the evaluation. We end up with r cubed times r cosine theta. Let's clean that up a little bit. R cosine theta plus 3. And at 0, it's 0. And do be careful here. Make sure you're using parentheses. Obviously, we've got to make some distribution when I do the algebra on this thing. So now we'll get the integral from minus pi over 2 to pi over 2. An integral from 0 to 2 of r to the 4th cosine theta plus 3r cubed dr d theta. So again, be very careful when you're working through these things. Parentheses are really useful to make sure that you don't miss some distribution. Because this is now just a double integral over the region D in polar coordinates, I leave the rest to you to finish it out.